This is Unit 2 of Exploring Core Data Concepts, part of the learning materials from Microsoft for the DP-900 certification. Identifying the need for data solutions. Data is now easier to collect and cheaper to host, making it accessible for nearly every business. Data solutions include software technologies and platforms that can help facilitate the collection, analysis and storage of valuable information. Every business would like to grow their revenues and make larger profits. In this competitive market, data is a valuable asset, and when analysed properly, can turn into a wealth of useful information and inform critical business decisions. So what is data? Data is a collection of facts such as numbers, descriptions, and observations used in decision making. You can classify data as structured, semi-structured, or unstructured. Structured data is typically tabular data that is represented by rows and columns in a database, similar to a spreadsheet. Databases that hold tables in this form are called relational databases. The mathematical term relation refers to an organised set of data held as a table. Each row in a table has the same set of columns. The image below illustrates an example showing two tables in an e-commerce database. The first contains the details of customers for an organisation, and the second contains information about products that the organisation sells. Semi-structured data is information that doesn't reside in a relational database, but has some structure to it. Examples include documents held in JavaScript object notation, otherwise known as JSON format. The example below shows a pair of documents representing customer information. In both cases, each customer document includes child documents containing the name and address, but the fields in these child documents vary between customers. There are other types of semi-structured data as well. Examples include key value stores and graph databases. A key value store is similar to a relational table, except that each row can have any number of columns. You can use a graph database to store and query information about complex relationships. A graph contains nodes, which is information about objects, and edges, which is information about the relationships between those objects. The image below shows an example of how you might structure the data in a graph database. Not all data is structured, or even semi-structured. For example, audio and video files and binary data files might not have a specific structure. They are referred to as unstructured data. So how is data defined and stored in cloud computing? Depending on the type of data, such as structured, semi-structured, or unstructured data, it will be stored differently. Structured data is typically stored in a relational database, such as SQL Server or Azure SQL Database. Azure SQL Database is a service that runs in the cloud. You can use it to create and access relational tables. The service is managed and run by Azure. You just specify that you want a database server to be created. The act of setting up the database server is called provisioning. You can provision other services as well in Azure. For example, if you want to store unstructured data such as video or audio files, you can use the Azure Blob storage. Blob is an acronym for Binary Large Object. If you want to store semi-structured data, such as documents, you can use a service such as Azure Cosmos DB. After your service is provisioned, the service needs to be configured so that users can be given access to the data. You can typically define several levels of access. Read-only access means that the users can read the data, but they can't modify any existing data or create new data. Read-write access gives users the ability to view and modify existing data. Owner privilege gives full access to the data, including managing the security, like adding new users and removing access to existing users. You can also define which users should be allowed to access the data in the first place. If your data is sensitive or secret, you may want to restrict access to a few selected users. Describing data processing solutions. Data processing solutions often fall into one of two broad categories: analytical systems and transactional processing systems. What is a transactional system? A transactional system is often what most people consider the primary function of business computing. A transactional system records transactions. A transaction could be financial, such as the movement of money between accounts in a banking system, or it might be part of a retail system, tracking payments for goods and services from customers. Think of a transaction as a small discrete unit of work. Transactional systems are often high volume, sometimes handling many millions of transactions in a single day. The data being processed has to be accessible very quickly. The work performed by transactional systems is often referred to as online transactional processing, or OLTP. To support fast processing, the data in a transactional system is often divided into small pieces. For example, if you're using a relational system, each table involved in a transaction only contains the columns necessary to perform the transactional task. In the bank transfer example, a table holding information about the funds in the account might only contain the account number and the current balance. Other tables not involved in the transfer operation would hold information such as the name and address of the customer and the account history. Splitting tables out into separate groups of columns like this is called normalized. The next unit discusses this process in more detail. Normalization can enable a transactional system to cache much of the information required to perform transactions in memory and speed throughput. Normalization can enable a transactional system to cache much of the information required to perform transactions in memory and speed throughput. While normalization enables fast throughput for transactions, it can make querying more complex. Queries involving normalized tables will frequently need to join the data held across several tables back together again. This can make it difficult for business users who might need to examine the data. So what is an analytical system? In contrast to systems designed to support OLTP, an analytical system is designed to support business users who need to query data and gain a big picture view of the information held in a database. Analytical systems are concerned with capturing raw data and using it to generate insights. An organization can use these insights to make business decisions. For example, detailed insights for a manufacturing company might include trends enabling them to determine which product lines to focus on for profitability. Most analytical data processing systems need to perform similar tasks: data ingestion, data transformation, data querying, and data visualization. The image below illustrates the components in a typical data processing system. Data ingestion is the process of capturing the raw data. This data could be taken from control devices measuring environmental information, such as temperature and pressure, point of sale devices recording the items purchased by a customer in a supermarket, financial data recording the movement of money between bank accounts, and weather data from weather stations. Some of this data might come from a separate OLTP system. To process and analyze this data, you must first store the data in a repository of some sort. The repository could be a file store, a document database, or even a relational database. Data transformation and data processing. The raw data might not be in a format that is suitable for querying. The data might contain anomalies that should be filtered out, or may require transforming in some way. For example, dates or addresses might need to be converted into a standard format. After data is ingested into a data repository, you may want to do some cleaning operations and remove any questionable or invalid data, or perform some aggregations such as calculating profit, margin, and other key performance metrics, otherwise known as KPIs. KPIs are how businesses are measured for growth and performance. Data querying. After data is ingested and transformed, you can query the data to analyze it. You may be looking for trends or attempting to determine the cause of problems in your systems. Many database management systems provide tools to enable you to perform ad hoc queries against your data and generate regular reports. Data visualization. Data represented in tables such as rows and columns or as documents aren't always intuitive. Visualizing the data can often be useful as a tool for examining data. You can generate charts such as bar charts, line charts, plot results on geographical maps, pie charts, or illustrate how data changes over time. Microsoft offers visualization tools like Power BI to provide rich graphical representation of your data.